Let's look at the moment-generating function for discrete random variables. Recall that the moment-generating function is m of t. It's the expected value of e to the xt. Suppose that the discrete random variable x has this distribution. F of x equals 1/2 when x equals 1. In other words, the probability that x equals 1 is a half. The probability that x equals 2 is 3/8. And the probability that x equals 3 is 1/8. Find the moment-generating function m of t. Well, for a discrete random variable x, we know that the expected value of g of x is the sum over all x of g of x f of x. So the expected value of e to the xt is going to be the sum over all x, e to the xt f of x. The variable x takes on only three values, 1, 2, and 3, so it's easy to compute this sum. M of t, the expected value of e to the xt, is just the sum of e to the xt f of x. So x might be 1, in which case we get this term here, e to the 1t f of 1. X can also take on the value 2, so we get this term here. And x can take on the value 3, so it leads to this term. So in other words, we get e to the 1t times a half plus e to the 2t times 3/8 plus e to the 3t times 1/8. And that's the answer that we end up with, as you can see there. Use the moment-generating function to find the mean of x. Okay, the mean of x is the expected value of x, which is m prime of 0. M of t is half e to the t plus 3/8 e to the 2t plus 1/8 e to the 3t. The derivative m prime of t is going to be 1/2 e to the t plus 2 times 3/8 e to the 2t. The 2 comes from the fact that we're differentiating e to the 2t plus 3 times 1/8 e to the 3t. So that works out to be half e to the t plus 6/8 e to the 2t plus 3/8 e to the 3t. When we plug in 0, all of the e to the zeros over here, those are all just 1. And so we end up with half plus 6/8 plus 3/8. And when you find the least common denominator, you end up with 13/8. So the mean of x is 13/8. Use the moment-generating function to find the variance of x. Well, the variance of x is the expected value of x squared minus the expected value of x squared. That's m double prime of 0 minus m prime of 0 squared. M prime we saw earlier. M double prime, again, that will be half e to the t plus 12/8 e to the 2t plus 9/8 e to the 3t. Again, the 2 and the 3 come down when you're differentiating m prime of t. M double prime of 0 plugs 0 into here, and m double prime of 0 turns out to be half plus 12/8 plus 9/8. In other words, 25/8. So the variance of x is going to be the expected value of x squared minus the expected value of x squared. That's m double prime of 0 minus m prime of 0. M double prime of 0, as we just saw a moment ago, was 25/8. M prime of 0, we calculated that in the previous screen, that's 13/8. So it's 25/8 minus 13/8 squared. And if you do the math, that turns out to be 31/64.